Welcome to this unit where we will go through the MRP algorithm, and I'm going to be using a spreadsheet for doing this. What you may want to do before we go through this lesson is you may want to print off the Word document, which I'm now displaying, and that Word document is called the MRP procedure. And this shows the narrative procedure for the MRP algorithm. Now let me say a couple of things before we actually get started doing this. The first is that the procedure in the Word document you will not find in your textbook. This is something that I have developed to aid my students. The second thing is the MRP procedure is going to look weird. It's going to sound weird. But it's really not weird. It's been around for quite a while. And the more you do it, the easier it's going to be to do it. And I'm going to expect you to be able to do this not only for homework purposes, but also for exam purposes. So this is important. Now, there are some students who are visual learners, and as we go through the spreadsheet calculations, you can learn the steps visually just by following along. There's another group of students who need to have a procedure in order to learn, and it is for this group of students that I have written this narrative. So hopefully you know which of those two groups that you fall in. So if you're the group that needs the narrative procedure, I recommend that you print out a hard copy of this document as we go through it. If you're the type that learns visually, you may not need to do that, and you can learn the procedure just by watching me go through the steps. So now I'm going to switch back to the spreadsheet and go through the MRP procedure. So we have a diagram over here on the right-hand side for our bill of material. That's one of the inputs that's required. So in this example, we are producing product A, and in order to produce product A, it requires two components. It requires two B's to make one A, and it requires four C's to make one A. Now, B is actually a sub-assembly. It has a component required to make it, and it also uses C. It takes two C's in order to make 1B. So you can see that the component C is used on two different levels of the bill of material. It's used on level 1, and it's also used on level 2. So its low-level code is level 2 in this case. So that means in our MRP planning that we cannot complete the planning for component C until we get to level 2 of the bill of material. Now we know from the previous lectures on MRP that MRP does level by level planning. So we're going to start with the level 0 planning. And I'm going to read verbatim from the procedure to begin with here. And the procedure says that we are going to determine the gross requirements for the finished part from the master production schedule or the forecast. And the gross requirements for level 0 will be the same quantity and timing period as the master schedule. So here's our master schedule. So we have need 50 in time period 4, another 50 in time period 6, and finally a third 50 in time period 8. And so the gross requirements for part A are going to be exactly the same as the master schedule. So we're essentially just copying the master schedule data down to the gross requirements line. The second step in the procedure says to calculate the on-hand inventory for the first time period using a formula that the projected on-hand inventory is equal to the inventory projected on-hand in the previous time period minus any gross requirements in the current time period plus any scheduled receipts. So here's our projected on-hand inventory row of the spreadsheet. We're going to do the calculation here. So in time period, we're assuming we're at time period 1, and our on-hand inventory for time period 1 is 0. So we're starting out with 0. We have 0 gross requirements. I'm going to go ahead and enter in 0 values in these cells here, just so you're aware that we have that those are, if it's blank, it's the same as 0. So we start off with 0. We have 0 demand. A scheduled receipt is a supply coming in. So 0 minus 0 plus 0 is going to be 0 as well. Let me go ahead and put in 0 values in these scheduled receipts cells as well. Now we go to the next time period. The projected on-hand inventory for the next time period is going to be what we had before, minus any gross requirements in the current time period, plus any scheduled receipts. That also is a 0. Go to the next one. So 0 minus 0 plus 0 is again a 0. We go to the fourth time period. So we have projected on hand in the previous of 0. Now we have a gross requirement of 50 in this time period. So 0 minus 50 plus 0 is going to give us a negative 50. So what we discussed in the lecture is whenever the projected on-hand inventory becomes a negative number, that indicates that we need a supply of material to come in that time period. Otherwise, we're going to be short. So think of this as similar to your checking account. If the projected on-hand inventory is the projected balance in your checking account, it says in 4 days, you're going to run out of money. And you don't want to run out of money. So we have a problem here that we have to deal with. So looking at the procedure, looking at the next step, it says that we should determine the net requirement. So the net required is the absolute value of the projected on hand. So the absolute value of negative 50 is a positive 50. Now I'm now looking at the procedure. I'm looking at step number 5 now. It says to create a planned order whose receipt date is the same time period as the net requirement. So the planned order receipt date is going to be in time period 4. And also step 5 says the quantity of the planned order is determined by the lot size policy for this part. So we look at the lot size policy for this part, and the lot size policy is lot for lot. And you recall from the previous lecture, the definition of lot for lot is what you need is what you get. So if I need 50, what I'm going to produce is exactly that, not one more, not one less. Now, step number 6 of your procedure says determine the planned order release date using the formula. The planned order release date is equal to the planned order receipt date minus the lead time. Well, the planned order receipt date is time period 4. The lead time for this part is 1 time period. It means we must begin 1 time period earlier so that it can complete in time period 4. So I'm going to backward schedule 1 time period, and that is going to mean that I have a 50 in time period 3. So again, those 50 are going to be released in time period 3. They're going to be completed in time period 4. That is going to cover the projected shortage that would have occurred in time period 4. Now, students, the way that I teach the MRP algorithm is a little different from your textbook. It's the way that I was taught a long time ago, and it's the way that I prefer to teach it. And the way that I prefer to teach it is I like to see in the projected on-hand inventory, whenever we go shortage, I like to see the negative number appear. Now, what your textbook does is something like this. It shows a zero value. And the reason why it does that, it says, well, we're going to have 50 come in time period 4. They're going to be used to satisfy this 50 here, and so the result is going to be 0. And that's true. That's mathematically true. So it doesn't really matter whether you use your book procedure, which is to put a 0 there, or you use my nomenclature, which is a negative number. You're going to get exactly the same answer. The two most important rows in this MRP procedure spreadsheet are going to be the planned order receipt row and the planned order release row. And they're going to be the same which of the two procedures that you have. So your procedure says to continue along with this particular level here. So we're not finished with level 0 yet. So we have to go now to time period 5. So we had a 0 projected on-hand inventory for the previous time period, minus 0 plus 0. That's going to give us a 0 again. When we go to time period 8, we have 0 minus 50 plus 0. Again, we have a projected shortage occur, in time period 6. So the procedure says when that becomes a negative number, we need to calculate the net required, which is the absolute value of the projected on hand. And the procedure says that we need to create a planned order whose date is the same as the net required and whose quantity is determined by the lot size policy. Again, the lot size policy is lot for lot. So it means we're going to have 50 completed in this time period. And then in order for those 50 to be completed in that time period, they need to be started in the previous time period. So we have almost finished with level 0. So we'll go back to the projected on-hand row again. So our projected on-hand in time period 7 is going to be 0. When we go out to time period 8, our projected on-hand is going to be 0 minus 50 plus 0. Forgot to put that 0 there. Let me add that in. So we have another negative 50 once again. And our net required will be 50. So our planned order receipt will be 50. And our planned order release will be 50 in time period 7. So this completes the planning for level 0. So if you'll take a look at your procedure, if you're using the procedure, you'll see after step 7, there is a row in your Word file that says level 1 through level N planning. So now we're going to go down to step 8 of the procedure. Step 8 says to calculate the gross requirements for the dependent demand. And dependent demand is always calculated. It is always calculated. So to calculate the dependent demand for part B, so it takes 2 B's in order to make 1 A. So if I need to start 50 A's in time period 3, and it takes 2 B's to make 1 A, 50 times 2 is going to be equal to 100. Also, in time period 5, I need to start 50 A's. And in order to start those, it's going to require another 100 B's. So again, that 100 is the calculated value of 50 times 2, because the bill of materials says it takes 2 B's to make 1 A. And then finally, I made a mistake there. Let me change that. Okay, finally in time period 7, I have another 100 that's going to be needed. So I've calculated the gross requirements for the dependent demand part B. Let me calculate the gross requirements for the dependent part C. Taking a look at the diagram to the right, you see that it requires 4 C's in order to make 1A. 4 C's in order to make 1A. So the 50 A's that must begin in time period 3, how many C's will be needed in order to be able to start those 50? So 50 times 4 is 200. So that means we have a gross requirement of 200 in time period 2. I have another gross requirement for another 200 in time period 5. Finally, I have another gross requirement for 250 times 4 in time period 7. Now, since part C occurs on 2 bill of material levels, level 2 and level 3, I must suspend the planning for part number C until I have completed the planning for part number B, because that is going to produce more gross requirements for C, and I have to wait until I know what the total demand is for C before I can finish the planning for it. But I can go back and finish the planning for part B now. So using the same process that I had used for part A, I'm going to do the planning for part B. So my projected on-hand inventory in time period 1 for B will be what my beginning on-hand inventory is, which is 0. So the projected on-hand in time period 2 is going to be my previous projected on-hand minus any gross requirements plus any scheduled receipts. And I have a scheduled receipt for 50 in time period 2. Now, let me remind you what a scheduled receipt is. A scheduled receipt is an order that I had placed previous to today, maybe last week or sometime before that has not yet arrived, but is scheduled to arrive at some time in the future. So in this case, it's scheduled to arrive in the next time period. So I'm going to assume that it will arrive when it's scheduled to arrive, which means that I should have a projected on-hand inventory of 50 at the end of time period 2. So my projected on-hand inventory in the third time period will be 50 minus my gross requirement of 100 plus any scheduled receipts in this time period, which is 0. So 50 minus 100 is a negative 50. So I have a shortage projected for part B that will occur in time period 3. So my procedure says when this becomes a negative number, I need to calculate the net required. The net required is the absolute value of the projected on hand. I need to determine my planned order quantity, which is defined by the lot size policy for this part. In this example, the lot size policy for part B is a fixed lot size of 100. What that means is anytime that I need to produce B, for some valid reason, I am always going to produce 100. So even though I only need 50, my lot size quantity will be 100. So we always honor the lot size. We always honor it. So I'm going to produce 100. And when do those need to be started? I look at the lead time. for B, which is 2 time periods. I'm going to back off 2 time periods, do backwards scheduling, which means that those 100 have to be started in time period 1. So they're going to start in time period 1. They're going to complete in time period 3. I'm going to take 50 out of those 100, use it to satisfy this projected shortfall of 50 here, and the net result is I should have 50 units that are left over to carry me forward. I have no gross requirements in time period 4 or scheduled receipts, so my projected on hand in time period 4 is 50. So let me say again how I got the 50. I got 100 coming in. I'm going to take 50 out of that as my projected shortfall, and I should have 50 left over. Going to the next time period, the projected on hand will be my previous 50 minus the 100 plus the 0. So now I have another projected shortfall of another 50 in time period 5. The net required is going to be 50 as well. The lot size policy, again, fixed order quantity, always produce 100. I'm going to produce 100. When do those 100 need to begin? Back off 2 time periods, backward scheduling, and they need to start in time period 2. So once again, I've got 100 coming in. I'm going to take 50 out. That should leave me with a residual of 50 to carry forward to the next time period. Going to time period 7, I have 50 coming in. I need 100. I have no more scheduled receipts, so I have another projected shortfall of 50 in time period 7. So, once again, net required is 50. Planned order quantity, fixed order quantity, 100. Always produce 100. When do they need to start? 2 time periods, backward schedule. And finally, in time period 8, I'm going to end having 50 left over. So now I have completed the planning for part B. Now I can take the results of part B and I can calculate the remaining dependent demand requirements for part C. So in order to make 1B, it requires 2 C's. So over here, I need to start 100 B's in time period 1. How many C's are going to be required in order to start 100 B's? 100 times 2. So the gross requirements for C is I need another 200 in time period 1. I have another 100 B's that are required in time period 3. So I need another 200 C's in order to begin those 100. But I already have a requirement for 200 C's in the same time period. That 200 here was the result of the 50 A's that were needed. So therefore, my total demand for part C in the 3rd time period is the sum of these two. So 50 A's will require 200 C's. It takes 4 C's to make 1 A. 100 B's will require 200 C's. 200 plus 200 is 400. So my total demand in time period 3 is going to be 400. Again, I have the same situation occur in time period 5. So I need to release 100 B's in time period 5, which is going to require 200 C's. But I already have 200 Cs required in time period 5. So the total demand for time period for Cs in time period 5 is once again 400. That completes the requirements for the Cs. Okay. Now, I have finished planning level 1. I started with level 0. I have completed planning level 1. Now I can plan level 2, which is the C's here. So once again, I'm going to start with my projected on-hand inventory. So I have 0 inventory of C's coming in. And I have a gross requirement in time period 1 of 100. But I have a scheduled receipt. I have an order for C's that was placed sometime in the past that's scheduled to come in time period 1. So I'm assuming that that will, in fact, arrive. So my projected on hand will be 0 minus 200 plus 200, and that result will be 0. Going out to the second time period, I have 0 minus 0 plus 0. That gives me another 0. Going to the third time period, I have 0 minus 400 plus 0, and that's going to give me a projected shortfall of 400. So for C's, I'm going to run out in time period 3. That's where I have my material shortage problem. So my net required is going to be 400 in time period 3. Now the planned order quantity for Part C is determined by the lot size policy. And the lot size policy for Part C is 3 demand periods. 3 demand periods. So what that means is that I need to create a quantity that will be equal to the sum of the demand of 3 consecutive time periods. Let me say that again. I need to create a quantity that will be equal to the sum of the demands of 3 consecutive time periods, beginning with the first time period where I have a shortage. So I have a shortage of 400 in time period 3. That's period number 1. Period number 2, I have no demand in period number 2. In period number 3, the third consecutive period, I do have another demand for 400. So in those 3 consecutive time periods, my total demand is 800. So that's 400 in time period 3, 400 in time period 5, 0 in time period 4. That gives me a 800 that is needed. Now, when do we need to start on these 800 so that they're finished in time period 3? I look at my lead time for the part. It says 3 time periods. So I need to backward schedule 3 time periods. So 1, 2, oops, I ran out of time. Let me do that again. Go back, I need them here. 1, 2, oops. What happened? It says I needed them yesterday. It says I needed them last week. Does this happen in the real world? It happens all the time. It happens every day. So, how's MRP going to deal with this situation? It says you should have done something in the past, but you didn't do it. That's like saying you should have done your homework on a certain date that it was due, but you didn't do it. Is there any way to go back in the past and do something that hasn't been done? Well, the answer is yes, but they haven't invented the machine yet. But the only way to do something in the past that has not been done is to jump in your time machine and go back in time and do it. Well, we don't have a time machine. So the way MRP is going to deal with this is what is the first feasible time period that I could, in fact, begin this. The first feasible time period is time period 1, which is today. So it's going to plan those 800 to be started in time period 8. But I need to honor my lead time. So when will those actually be finished? So this planned order receipt quantity actually is not going to be happening in time period 3. It's going to be happening in time period 4 because it takes 3 time periods. Now I'm doing forward scheduling. 1, 2, 3. That's when it's going to be completed in time period 4. Now, here's what's going to happen in the real world. MRP is going to detect this as an exception message. You have something arriving after it's really needed. So it's going to produce an exception message and tell you, you've got a problem. You need to do something about this. MRP can't take the action because it doesn't know what is feasible that could be done, but it's going to alert you that there's a problem and you need to deal with it in some way. So, finishing the planning for Part C. We have 800 that are going to be coming in. So the projected on-hand inventory in time period 4 is going to be 400. So I'm going to take 400 out of the 800, and that leaves me with another 400. In time period 5, the projected on-hand will be 400 minus 400 plus 0. That takes me down to 0. In time period 5, projected on-hand is 0. In time period 7, my projected on-hand is 0 minus 200 plus 0, which gives me a minus 200. So I have another projected shortfall that should occur in time period 7. What's the net required quantity in time period 7? The absolute value, 200. What is the planned order quantity going to be? Go back to the lot size policy. It says the quantity needs to be a quantity that is the sum of 3 consecutive demand periods, beginning with the 200 that's needed in time period 7. So we have 200. In the time period 8, we have 0. We're assuming for our planning purposes, this is the end of the world, that we don't have the next time period. Of course, that's not really true. So 200 plus 0 plus another 0 is 200, 3 consecutive time periods, a total of 200. And when do those need to begin? Now, in this case, I can honor the 3 backwards schedule, the 3 time periods, 1, 2, 3. And so those 200 need to begin in time period 4 so that they can arrive in time period 7. That will cover the shortage projected there. And so finally in time period 8, I have a 0 projected taking place. So this completes the MRP algorithm. Once again, I know it sounds a little confusing to you, but this is the way it works. As you do this several times, it will start to make more sense to you what we're doing, and I do expect you to be able to do it. Now, before we leave this lecture, there's another point that I want to highlight in this example. Let's go back and look at the planning for Part A. If we look at the planning for Part A, we need to start 50 A's in time period 3. Well, let's do a little analysis on Part C. How many C's are required in order to make 1A? How many C's are required to make 1A? Well, if you look at the diagram, it takes 4 C's to make 1A. and it takes 2 C's to make 1 B. So therefore, it takes, going through the B level, it takes another 4 C's to make 1 A, going down through the B level. So 1 times 2 is 2. 2 times 2 is 4. Over here you have 1 times 4 is 4. So we have 4 going down to the right, 4 going down to the left. 4 plus 4 is 8. So it takes 8 C's to make 1A. 8 C's to make 1A. So if I need to make 50 A's, how many C's should I need? What is 8 times 50? 8 times 50 is 400. Well, can you answer this question for me? If I need 400 C's in order to make these 50 A's, then why does my MRP plan say that I need 800? That's twice the amount that I need. How did that come about, that I need 800? Is there a mistake here? The answer is no, there's not a mistake. We follow the MRP algorithm perfectly. But what has caused this essentially doubling of requirements is what is referred to as the cascading effect of lot sizing. The cascading effect of lot sizing. So the lot size policy for Part B was a fixed order quantity. What that did is that required us to produce twice as much, in this example, twice as much of what we actually needed. And so that is the cascading of effect of lot sizing is like going to the top of a snow-packed mountain and starting a snowball and rolling it down the mountain. And what's going to happen to that snowball? It's going to get bigger as it goes down the mountain. Well, the same thing is going to occur here, that these lot size policies of one fixed order, and then for C, for the 3 time periods, compounded and increased the quantity that's needed. So MRP assumes that when you are defining your lot size policies, that you know what you're doing and you understand the effect of cascading in lot sizing. So please be careful if you're doing this to where you're not getting this increase in inventory that's required as a result of this. This concludes this lecture on the MRP algorithm.